Marieke van the Schaaf. She's already been involved in the NMCB right from the start. Our MRI protocol and our cognitive testing protocol was co-developed by her, or maybe fully developed by her, together with Guido particularly. And I'm very glad that you also have now a project funded and that you now are active officially. Yeah. Thank you. Looking forward to your presentation.
Yes, thank you. So my project, so this project just started last week. So I'm just going to show you the plans that we have with the project. And it's called Investigating Metabolic and Neuropathological Interactions to Address Cognitive Symptoms in MECFS. So MECFS and also post-COVID, patients often experience cognitive symptoms or brain fog, but it's still very unclear what is actually underlying these symptoms. If you look into the neuropsychological test assessments, often you get mixed results where the test assessments do not always correlate with what people report having the types of symptoms that they have. And usually these tests are developed to measure organic damage within the brain. If you ask patients about the type of symptoms that they have, it's often that they indicate it's very dynamic. It's more problems with sustaining attention, for example, or processing speed is basically the most consistent finding with regard to cognitive function in patients. So this also suggests that we somehow need to think differently about what is causing the cognitive problems in these patients. And then if you look into the brain, the work of people also from the NMCB in the post-COVID group showed that changes in the chirin pathway, probably linked to changes in the enzyme of ADO2, might actually lead to changes within the brain, either with changes in the monoamine functioning or mitochondrial functioning, or also neurotoxicity. So this raises different hypotheses on what might be happening within the brain. And based on this, there is a need to better understand the nature of cognitive symptoms and also the neurobiology of these symptoms, but also to translate this knowledge into how can we improve the neuropsychological testing to better capture the cognitive symptoms of these patients. So that's led to the main research question that we want to answer with our project is how do central neuropathologies measured with MRI in the brain link to neurocognitive impairments and peripheral immune metabolic profiles in MECFS. And based on current findings or current hypothesis, we want to dissociate between two profiles. One that is more focused on processes that lead to neuronal changes within the brain, like neurotoxicity and apoptosis, and these might be related to more the classical domains of neuropsychological testing, while other profile might be more related to things like energy metabolism and monoamine functioning, and these might more be related to these dynamic changes within cognition. So we will use the data of the biobank. We are currently setting up all the MRI procedures. Hopefully we will start with that in the upcoming month in Nijmegen and also in Amsterdam and Leiden. And we will assess a series of different MRI sequences that allows us to measure different microanatomical changes within the brain, as well as functional changes. And we also assess a spectroscopy that allows to measure several metabolites within the brain. And with that, we also use the cognitive testing within the NMCB and the various questionnaires that are assessed. And we will, together with our immune and metabolome collaborators, we will also assess the blood samples. And we will try to find links between those where we take into account these different profiles, more neurodegenerative profile and a more metabolic profile. So we hope that this will provide some new neurobiological insights into understanding cognitive symptoms in MECFS, and we try to think beyond the classical neuropsychological test assessments. Hopefully that will contribute to the current developments on how we think about cognition, that it's not only brain structure, but it might also be energetic or metabolic processes that might contribute to it. And also if you talk with patients, we know that there's a high need to better understand this. And ultimately we hope that this might provide insights for new treatments and improve assessments for cognitive related symptoms in MECFS. And this is the team. So Ilke de Lange is the PhD student who's going to do everything. And we have a neuroimaging and cognition team across the 3 centers that are collecting the MRI data, including Esther Aerts in Nijmegen, Guido van Wingen here in Amsterdam, and then we also have people in Leiden and Tilburg. And we have a team that is more specialized on immune metabolism, including Ruud Raamakers, who is here, and René Lutter. And we have several patient representatives that help us with this. Michelle and Inge helped us really a lot with the proposal. And then Justine and Ruud are now helping us out with the start of the project. That was it.
There are questions online, if no one here wants to go first.
Anyone? No.
Thanks. Glutamatergic dysregulation, more directly linked to gliosis and a loss of glial scavenging of, for example, glutamate, has been shown in long COVID recently. Wouldn't it be an idea to try that too instead of MRI changes or functional MRI changes?
Yes. We are going to look at glutamate. So we are going to do MR spectroscopy, which allows us to measure various metabolites, and that also includes glutamate.
There's someone who is stating, or I don't know if it's a question, maybe also an idea to measure cerebral blood flow during testing.
Yes, so there are many different MRI sequences that we can do. So there will be an ASL scan, which measures cerebral blood flow. We focus on different measures, but there's, of course, always extra measures that you can do. So we need to select.
We do ask. The answer is yeah, and we're using the same patient. So yeah, we are doing cerebral blood flow as one of the sequences, and so we try to combine those studies. So the assessments that Marieke will do will be in the same patients who will also do the other scans, which simply means they have to stay in the scanner a few minutes longer. And so we hope to combine those studies. And that's one of the major advantages of being in such a large consortium, that we can make use of each other's knowledge and measurements. And also it's less exhaustive for patients, because with one study, with one assessment, they basically are data is collected for multiple studies. And so it's a win-win.
I have some more questions from online. What is your opinion on the tests conducted by Cardiozorg and addressed in the legal process of last spring? It's called, I believe, 2-back and 3-back, for instance.
The NBAC task. We're not doing that in this. So we are not doing task-related MRI in this protocol. I think it's. There are mixed results on the NBAC task if you look into the literature. So it's NBAC task is a cognitive task where people have to look at numbers and say, well, this is the same number as 2 or 3 or 1 thing before.
So you see 25, 14, 12, and then you have to say 2 numbers back?
Yes. Yeah, you have to keep the numbers in mind. So it's quite an and depending on how much back in time you need to remember, the cognitive load increases. I find it very difficult to give a clear answer on that right now. I think it's also a sustained attention task, and it requires a lot of it's a high load task. So that is one thing. If you think about, for example, sustained attention, if you think about fatigue or limited cognitive resources, then you could also expect that people might be good at the beginning, but then it deteriorates quicker than in healthy people. So there are different ways of looking at those tasks. And that is also what we are going to do with the cognitive testing, is that we're not going to look at just at averages, but also how people change over time.
Okay, good.